Okay. Questions from you guys? Maddie? Okay. All right, so Maddie, which variable did you choose to try to eliminate first? Okay. So to eliminate the z's, what did you do? Yep. No, I trust that you probably were. So what equations did you add together? That's what I'm asking.
The first one was 2a plus b, negative 2.
Okay.
And it was 3 plus 2c.
Okay, those should both work. So when I do negative 2 times a, negative 6x minus 10y plus 4z equals negative 26. I have negative 5x minus 2y minus 4z is equal to 20. When I add that down, I get negative 11x minus 12y equals negative 6. And then b, I'll just recopy. And then 2 times c gives me negative 28x minus 34y plus 4z is equal to negative 38. So when I do that, I have negative 33x minus 36y equals negative 18. So those become a new system. We'll call those equations D and E. Matt, do you feel good so far? Okay. And then at this point, you might not have even needed to solve to see that this is going to be infinitely many solutions. You should have been able to identify that D is equal to, or 3 times D is equal to E. But if you wanted to, you could have multiplied one of them by negative 3 and then added them together to get 0 equals 0. I'm just going to do this just to save myself the writing. Okay, there. So now I need to formulate my parametric answer. So what I'm going to do is I'm going to pick one of these two variable equations. I'm going to pick the first one because the numbers are smaller, the coefficients. And I'm going to, from that first equation, isolate either the y, well, I should say the x or the z. I don't know why I wrote y in there twice, huh? That's confusing. So if I look at this, it doesn't really matter there, right? One isn't any easier than the other. So for the sake of argument, let's isolate the x. Okay with that? So I'll add the 12y to both sides and then divide by negative 11. So that gives me my first component for my answer. Tells me how to find my x. And then because I've written that component in terms of y, I know the y is like the independent variable, so the y is just y. And then to find my last component for my answer, the z, I'm going to take this answer for x and plug it back into any of the 3 variable places and solve for, and then isolate z. So just for the sake of argument, let's plug it into the first one. 13, I think. Okay, there. And now I just have a bunch of crummy fractions to have to sort through, right? So we'll distribute that 3, so that gives me negative 36 over 11y plus 18 over 11. Now 5y I'm going to have to add to the 36 over 11y, so let's make a common denominator of 11. So that'll be 55 over 11. And eventually I'm going to have to add or combine this 18 over 11 and this 13. So again, let's make a common denominator. So 11 times 13 is 169. Is that right? Let me check real quick on the calculator. Oh, way off. 143. Oh, sure. I'm done. Okay. So is that okay, Maddie? Okay. So combine some like terms. So 55 and 36 gives us 19. Or I should say negative 36 and 55 gives us 19. And if I subtract that 18 over 11 from both sides, it gives us 125 over 11. And then I'll subtract that 19 over 11y to the other side. And then I'll multiply both sides by negative 1/2, which is the same as dividing by negative 2. It's just a little bit more convenient to think about it that way since I have fractions involved. And I just switched the order with the subtraction rather than switching the signs and keeping them in the same place. It just felt like less writing to me. So that should be my third component then for my answer. Now keep in mind there's 3 versions of a correct answer here that you could have had, Maddie, depending on whether you wrote your parametric solution in terms of x, y's, or z's. So this is one of 3 possible answers that you could have written. And I'm pretty sure that's correct. Let me just check real quick. I wrote down the answers here for myself before we move on, right? If there's a boo-boo in here, we should probably find it somewhere. But if it is, it would just be like an arithmetic boo-boo. No, you don't find y. Y is like the independent variable. So because you have infinitely many choices for y, you get infinitely many solutions because you pick a value for y and then that allows you to find the other 2 coordinates that go with it. Does that make sense? So this is just describing to you how you can find those infinitely many solutions. My answer key, I have a 24 as the denominator instead of a 22, but that feels like it's almost certainly got to be a typo on my part. Did I boo-boo that somewhere? Did anybody notice a boo-boo? Let's look real quick. You got 22? Okay. Did you get all the same numerators and stuff?
Yeah, I just wrote the sign somewhere, but other than that.
Okay. Okay. Well, I assume that'll be right. Then I'll have to go back and double check that answer key I wrote for myself before I publish it for you guys. Okay. What's next? It's one of the Sydney's. Hines. Yes. On the same sheet?
Yes.
Sure. So which variable did you choose to eliminate first? Okay. And how did you do that?
I did A plus B.
Okay.
And then also 4C. No, yeah. Sorry.
It's okay.
A plus C, and then
Okay.
also B plus 4.
B plus 4C. Okay. So A plus C, we don't have to really rewrite anything, right? Because they're both written down there. So x and negative x give us 0. Negative y and positive y give us 0. Negative 2z and positive 2z give us 0. And then 4 and negative 3 gives us 1. We're done at this point right here. Since that's not a true statement, this is no solution when it's finished. You don't have to do anything else. It's over. Does that feel okay? So that was lovely, right? Much quicker than the previous ones.
So we found out a different solution right there, right? Is there like a whatever you can tell if there's a solution or not, like right here or like what actually?
If any point along the way you get like something that's not true, like 0 equals 5 or like 7 equals 10, it's no solution. And just in general here, like you could tell from looking, because if you look at the left-hand sides of there, you notice that those two left-hand sides are opposites, but the right-hand sides are not opposites. Right then and there, I knew it was going to be no solution before I did anything. You could make that explanation, or you could just add the 2 and show that 0 equals 1. Like if what you wrote down, what I did here, I don't think that's any less work than explaining what I just explained to you by looking at the equations. But either is fine with me, as long as you've clearly demonstrated like how you knew it was no solution. I'd be fine with however you chose to do that. Anthony. Uh-huh. Come on. All right. So Anthony, which variable did you try to eliminate first? X, Y, or Z? Okay. And then can you tell me what you added together to try to do that? Okay. So what you're going to look for is you're going to just pick any pair. So let's say we pick A and B. If I look at the coefficients for A and B, the coefficient for A is -3, and the coefficient for B is 6. If I want to add those together so that the z's cancel out, they wouldn't right there. But is there a number that both 3 and 6 go into? Sure. 6, right? So let's change the coefficients so that they're 6 and negative 6. So I'll multiply A by 2, and then B I don't have to multiply by anything because its coefficient is already 6. Does that feel okay? Okay. Now let's pick a different pair of equations, maybe A and C. If I look at the coefficients on the z's there, one is negative 3 and the other is positive 1. I want them to be opposite, so what's a number that both 1 and 3 go into? Well, 3, right? So let's multiply just equation C by 3 to make its coefficient 3. So just do A plus 3 times C. So now let's write down what we have. So 2 times A, so negative 6 minus 2y minus 6c is equal to negative 16. And then my B, just recopy. When I add those down, I get a negative 11x plus 1y. The z's cancel out, is equal to negative 20. Does that feel okay? And now we'll just do the other set. So copy down A, and then 3 times C, so that's negative 18 minus 12 plus 3z equals negative 60. So that's going to be negative 21x minus 13y is equal to negative 68. So that'll be our equations D and E. Does that feel okay so far? Okay, now we'll do the same thing. We'll pick a variable to eliminate. I would pick the y's because I can just do 13 times D plus E. 11 times 13 is 143. 13 times 1 is 13, and 13 times 26 is, or times 20 is 260. And negative 1, or 21, negative 13, negative 68. So that's negative 154x. The y's canceled out. And then negative 328 there. Oops. That's 164. Excuse me. Arithmetic is hard sometimes, you know. And if I divide both sides by negative 164, I get 2. Once I have that answer, I can go ahead and substitute it back in for either of the previous two equations. I'll plug it back into D, just because the numbers are a little bit smaller, but it doesn't really matter. So that gives me negative 22 plus y is equal to negative 20. Add 22 to both sides, and that gives me y. And then I'll take both of those answers and plug them back into A, B, or C. For the sake of argument, let's plug them into C. And that'll allow me to solve for D. I'm sorry, for Z. It's getting alphabet soupy up in here, huh? Negative 12 minus 8 plus C equals negative 20. And that's negative 20. So when I add it to both sides, I get 0. So my solution then is X, Y, Z. Does that feel okay? You're welcome. So again, these problems are a little long, right? But it helps, I think it helps a lot if we're able to stay kind of organized, to write down what we're doing, what we're supposed to be doing, the things that we're adding together. It's very difficult to kind of hold all this together in our head, to try to do big swaths of this in our head. And then if we make a little mistake somewhere, it's hard to identify where the problem is, to go back and figure out what happened if we didn't write down very much. So I think it really helps to kind of make sure you're writing down what you're doing and how you got intermediate steps. Go ahead. Sure. Okay. All right. So what variable are we going to try to eliminate here first? Well, that's, to be honest with you, it doesn't matter. Any is going to be fine. So whatever your first instinct was is a fine way to go. Sure. Okay. So what two equations do we want to add together to try to cancel out x first? Okay. That will work. Great. And what's another one? Negative 2a plus b. Sure. That'll work also. Okay? So negative 2 times c. I'll write down what that is. And then a I just can recopy. So I have 3y minus 5z is equal to 0. Then negative 2a and then b I'll just recopy. And I notice here that everything canceled out, right? That's fine. In fact, that makes life even easier, right? Instead of having to do 2 steps in our elimination, we just have to do 1. That's our a second set of elimination anyways. So that's fine. That's perfect. So all I'm going to do then is I'm going to use the equation that I have and isolate either y or z from it. It doesn't matter which one. Let's just choose to isolate the y. So I add 5z to both sides, and then I divide both sides by 3. That tells me I know the solution for my y component. It's 5/3 z. And I know that z is going to act like my independent variable. So all I need to do is find the y, or the x, excuse me. To do that, all I'm going to do is plug this value back into either a, b, or c. I'm going to choose to do it into c. So I have x minus 5/3 z plus z is equal to 0. If I take negative 5/3 and I add 1 to it, that gives me negative 2/3. I just made some common denominators there. Right, 1 is really just 3/3. And then to get x by itself, I just add 2/3 z to both sides. How did I get this? Because this piece was in terms of z. So whenever you solve the 2-variable equation to isolate the 1, you get 2 answers. You get which one is the independent variable, like in our case the z was the independent variable, and then you get the expression for the dependent variable for y in this case. You're welcome. Okay. Last call on questions from these. Doesn't mean we can't come back and ask more later, but I'm just saying for right now. Okay. Fair enough. Today, we're going to talk about we're going to be talking about solving systems from a story problem. So we're going to give you a story problem, and we're going to then formulate a system and solve that system. So I'm just going to steal from the homework assignment here. And we'll do a couple from this homework assignment together, and then we'll just let you guys kind of finish things up. Okay? So the first problem says the school that Lisa goes to is selling tickets to the annual talent show. On the first day of ticket sales, the school sold 4 senior citizen tickets and 5 student tickets for a total of $102. The school took in $126 the second day by selling 7 senior citizen tickets and 5 student tickets. What is the price of each senior citizen ticket the price each of 1 senior citizen ticket and 1 student ticket? Okay. So the first thing I would do in a situation like this is I would identify a name for the things that I'm solving for. Notice that we have clearly 2 variables, because we're asked for 2 things. One is the student or senior citizen ticket price, and one is the student ticket price. So I would say, let's make X the senior price and Y the student price. And I like to write those down so I don't forget. Normally I would pick letters that would be easy for me to remember which one is which, but since both of those start with S's, I didn't feel like using S and then capital S or something. It felt like a dumb idea since they look identical. So I just did X and Y. Everybody's okay so far? Okay, now we're given a bunch of information, right? We have what happened on day 1 and what happened on day 2. Hopefully that strikes you as, okay, I can use day 1 as one equation, and I can use day 2 as a second equation, right? And maybe we should really say that these are really rates, right? That's the price per ticket. You guys agree with that? Okay. So if I look at the day 1, I sold 4 senior citizen tickets and 5 student tickets for $102. So what is the equation there that I could write? Well, 4x. Yep. And then similarly, on the second day, what could I write? Anybody? Good. So there's my system. And I'll leave it to you guys to solve the system, right? We've spent enough time talking about that part that should be something we don't really need to do more examples on. Today we're really just working on kind of formulating story problems, right, into equations that we can solve. So this one was pretty easy. Let's skip a couple and maybe go on to some other one. Well, skimming through here, 2 maybe sounds like the next most interesting one because it's maybe not super obvious because it's so brief. It says flying with the wind, a plane went 130 or 183 kilometers per hour. Flying into the same wind, the plane only went 141 kilometers per hour. Find the speed of the plane in still air and the speed of the wind. So, how many things are we looking to solve for here? 2. What are they? Good. So let's say P for the speed of the plane. And I'll use W for the speed of the wind. Everybody okay with that? And here we're describing 2 situations, right? Those 2 situations are probably going to be our 2 equations. So the first situation says, flying with the wind, the plane went 183 kilometers per hour. What does with the wind mean? Yeah, the wind is pushing you. It's like behind you, blowing behind you, right? Like if you're sailing, that's the direction you want the wind pushing you, right? Okay, so how do I write an equation then? Good. P plus W equals 183. The second equation says flying into the same wind, the plane only went 141 kilometers per hour. Yeah. Good. There's your system. And that should be pretty easy to solve for, right? The elimination is like staring you in the face to do. Does that feel okay? All right. Those all felt very similar. What do we have on this next page? Well, these are just so easy. I stole this worksheet from somebody else, and these are so easy. That's okay. Let's do one more, and that'll be that, okay? So let's do this. We'll do this last one here. says Yellowstone National Park is a popular field trip destination. This year's senior class at High School A and senior class at High School B, these are originally named high schools, I'll tell you what, both planned trips there. The senior class at A rented and filled 7 vans and 10 buses with 32 students. High School B rented and filled 4 vans and 15 buses with 59 students. Each van and each bus carried the same number of students. Find the number of students in each van and in each bus. So, it should be pretty clear that we have 2 variables. So let's do V to be number of students per van. And I'll do B to be the number of students per bus. Everybody agree with that? Okay. So what's one equation I could write here? Need to make it bigger. It might be hard for you guys to read. Good. So 7V plus 10B is equal to 332. And then the other equation I'd write, good. Do you feel okay here? Hopefully this feels pretty manageable. Next time, the next topic is going to be a little bit, we're going to have some situations that are a little bit more challenging than this, but I wanted to make sure we started with something that felt pretty doable. Before I release you to kind of work on things, I want to do a homework quiz. So if you guys can take your tablets and open up the content library for me. Were you guys having bets on whether this was going to happen today?
Yes. We knew. I was telling that 4 or 5. I swear, if you have a homework quiz, I'm going to I just like go home. That's all. Please. I need to nap 3 to 3.
Okay.
We have to do the second one as we have to do that
Here's what I'm going to tell you. These are both have one solution to them. These are both one solution situations. And the solutions should be whole numbers if I did everything correctly. So let's try to do this in have this done in 10 minutes or something. With that additional removal of uncertainty about what's supposed to happen. Hopefully that becomes pretty realistic. This is in the content library. I just put it in there and synced it up. So if you sync your content library, you should see this thing pop up at the bottom as homework quiz 3. And then you can copy it into your own notebook and do it from there. Remember, you can make more space in between things if you run out of space. So just put your cursor in there and press enter, and you can make more space in between the problems. But these are both, let me check real quick before I say something I regret. Because I wrote them, but I didn't double check them. That's always a problem, right? Okay, so that's fine. Okay. So yeah, there's no issues there. I was not a liar. So I'm going to make the assignment here on Power School. And when you're finished, you can upload it into the Dropbox on Power School, the usual. Everybody's cool with that? The solutions are whole numbers for both of them. My suggestion to you is if that didn't happen on the first one, I would stop, do the second one, and then come back or whatever. Don't spend like a million years looking for some little typo that you made or some arithmetic error. Like, I would rather see the process and have the process be correct than just see like something, or nothing, or you know what I mean, guys? Like, don't leave something blank. Like, even if you have the wrong answer, like, write, I know this is wrong, but I can't find my stupid arithmetic mistake or whatever, and just keep going with it and finish the problem. Don't just stop when you know there's something wrong. Unless you can find what's wrong, right? But if, like, you looked at it for a couple minutes and you're like, yo, I don't know what I did here, just finish the problem up and write a note at the end. Be like, yeah, I know there's a mistake in here, but I couldn't find it and wanted to finish the problem. That tells me more about what you know than if you just leave stuff blank. You know what I'm saying? Ooh.